Hey, sleepers! Tonight, we're unraveling a cosmic mystery. The air is cool and still. Somewhere, a lone cricket chirps its nightly song. Above you, a velvet blanket of deep, dark space is dotted with a million pinpricks of ancient light. Each one a star, each one a sun. And around them, perhaps, worlds we can only dream of. We are listening tonight. Listening to the quiet hum of the universe. So before you get comfortable, take a moment to like the video and subscribe. We love to see how far our stories travel. So please, feel free to share your city or country and the local time in the comments below. It connects us all in this quiet moment before sleep. So close your eyes, take a deep breath, and get ready to drift off as we explore the alien signal that shocked astronomers. Let us travel back in time, not too far, just to the summer of 1977. It was a time of bell-bottoms and disco music, a time when the first Star Wars movie was captivating audiences, filling their heads with images of distant galaxies and strange creatures. The world was looking up. And in a quiet field in Delaware, Ohio, a giant piece of machinery was looking up too. It was listening. This was the Ohio State University Radio Observatory. But everyone who knew it, who worked there, who loved it, called it the Big Ear. And it truly was a giant ear. Imagine two huge metal fences lying on their sides, each one as long as 3 football fields laid end to end. They were static, unmoving, pointed at the sky. Between them was a massive flat metal plate, a reflector. It was not a sleek, modern satellite dish like you might picture. The Big Ear was beautifully, wonderfully, almost comically simple. It was built with wire mesh, like a giant screen door for the cosmos. It looked more like a piece of abstract art or a forgotten drive-in movie screen than a cutting-edge scientific instrument. The Big Ear didn't move to track stars. It couldn't swivel or turn. Instead, it used the Earth's own rotation as its guide. As our planet spun on its axis, different parts of the sky would drift through the telescope's narrow field of view. It was a patient kind of astronomy. You couldn't just point it at something interesting. You had to wait for something interesting to drift by. It was like fishing in a cosmic ocean. You cast your line and you wait. You listen. The man listening on August 15th, 1977, was Dr. Jerry Emmon. He wasn't at the telescope that night. He was a volunteer for the project. A professor who dedicated his free time to the search for extraterrestrial intelligence, or SETI. His job was to go through the data. In 1977, data didn't appear on a slick computer screen with beautiful graphics. It was printed out by a clunky, loud dot matrix printer on long, continuous sheets of perforated computer paper. It was a stream of numbers and letters, representing the intensity of the radio signals the Big Ear had picked up. Imagine Dr. Emmon, a few days after the 15th, sitting at a desk piled high with these printouts. The paper probably smelled of ink and warm electronics. The room would have been quiet, except for the rustle of the paper as he pulled another long sheet towards him. His job was to scan these columns of characters, looking for anything out of the ordinary. Most of it was just noise, the background hiss of the universe, the faint whispers of distant pulsars and quasars. The numbers were usually low. 1 south, 2 south, 3 south. It was a monotonous yet hopeful task. You are searching for a single meaningful word in a library filled with billions of books of random letters. And then he saw it. In a sea of 1 south and 2 south, there was a sudden, dramatic spike, a sequence of characters that made his heart jump. The sequence read 6EQUJ5. Let's take a moment to understand what those characters meant. The computer system at the big ear was programmed to represent signal strength. Numbers 1 through 9 represented intensities 1 to 9 times stronger than the background noise of space. Simple enough. But what if a signal was stronger than that? The programmers decided to use letters. A would mean an intensity of 10. B would be 11. C would be 12, and so on. The sequence Jerry Emmons saw began with a 6, a strong signal. Then an E, that's 14 times the background noise. Then a Q, that's a 26. A U, that's a 30. An intensity 30 times stronger than the normal quiet hiss of deep space. To put that in perspective, imagine you are in a library, a place of profound silence. You might hear the gentle rustle of a page turning. That is the background noise. Suddenly, for a brief moment, someone in the library shouts. Not just speaks loudly, but shouts. That's the kind of difference we are talking about. It was an astonishingly loud, clear signal. So loud, it almost maxed out the system's ability to record it. Dr. Emmons stared at the printout. He checked the data. He checked the time codes. It was real. The signal had arrived on August 15th at 10:16 p.m. Eastern, daylight time. It came from a part of the sky in the constellation of Sagittarius. And as he looked at this impossible string of characters, this shout from the cosmos, he grabbed a red pen. He circled the sequence 6EQUJ5, and in the margin he wrote a single, simple human word. A word that perfectly captured the shock, the awe, the sheer disbelief of the moment. He wrote, "Wow!" And so the signal was named. It would forever be known as the WOW signal. Let that feeling sink in for a moment. The quiet contemplation of a scientist. The sudden, world-shifting discovery. The simple, honest reaction. Wow! A word that connects the deepest mysteries of the universe to a feeling we all understand. It's the feeling you get when you see a beautiful sunset, the feeling of seeing a double rainbow, or the feeling of hearing a whisper from across the stars. Now let's look closer at this cosmic message in a bottle. What made it so special? It wasn't just its strength. It had other characteristics that made astronomers around the world sit up and pay attention. The first, and perhaps most important, was its duration. The signal lasted for 72 seconds. This number is incredibly significant. It's not a random length of time. Remember how the big ear telescope worked? It was fixed. It waited for the sky to drift by. The telescope's field of view was a specific size. Any radio source, a star, a galaxy, anything that passed through its listening window would be audible for exactly 72 seconds. Let's visualize this. Imagine you are sitting by the side of a road in complete darkness. You can only see a small patch of the road directly in front of you, illuminated by a flashlight. A car is driving down this road. You would first hear it faintly as it approaches your little circle of light. It would get louder and louder, reaching its maximum volume when it is directly in front of you. Then, as it drives away, it would get fainter and fainter until you couldn't hear it anymore. The WOW signal did exactly this. It started weak, grew in strength to its peak, and then faded away. And the total time from start to finish was 72 seconds. This told scientists that the signal was not from Earth. It was not a passing satellite or some stray radio transmission from a nearby town. It was coming from a fixed point in deep space. It behaved exactly like a distant star or galaxy passing through the telescope's gaze. This ruled out many earthly explanations right away. A signal from a ground-based source wouldn't fade in and out in that perfect, symmetrical way. A passing airplane or military satellite would have moved across the sky at a different speed. The 72-second duration was a perfect match for something located far, far beyond our solar system. The second key characteristic was its frequency. Every radio station you listen to in your car has a specific frequency. You tune your radio dial to find it. The wow signal also had a specific frequency. It was detected at 1420 megahertz. Or, to put it another way, 1.42 gigahertz. Now, this number might not seem special at first, but to an astronomer, especially one looking for alien life, this number is magical. It is the most famous frequency in all of radio astronomy. It is called the hydrogen line, or sometimes the 21-centimeter line. What is so special about hydrogen? Hydrogen is the simplest and most abundant element in the entire universe. It was the first element created in the Big Bang. It is the stuff that stars are made of. It is everywhere. The clouds of gas between stars are mostly hydrogen. The universe, in a very real sense, is made of hydrogen. And this element, this simple atom of one proton and one electron, naturally emits a faint radio signal at a very specific frequency, 1420 megahertz. It's like a tiny natural radio station broadcasting from every corner of the cosmos. It's the universe's background music. Think about it this way. If you wanted to get a message to someone, but you didn't know their language, what would you do? You would try to use a universal symbol, something you know they would understand. In mathematics, we have numbers like pi. In the cosmos, the hydrogen line is that universal symbol. For decades, scientists like Philip Morrison and Giuseppe Cocconi, pioneers of SETI, had theorized that if an intelligent civilization wanted to send a signal to other developing worlds, they wouldn't pick a random frequency. They would choose one that was obvious, one that any budding civilization of astronomers would eventually discover and pay attention to. The hydrogen line is the most logical choice. It is the most prominent signpost in the radio spectrum. It's like a cosmic meeting place, a universal water cooler where everyone in the galaxy might gather to chat. The wow signal was detected smack dab on the hydrogen line. It was as if someone had intentionally broadcast their signal on the universe's main calling frequency. It was another checkmark in the column for intelligent origin. The third and final piece of the puzzle was how narrow the signal was. The signal was what we call narrowband. Let's use another analogy. Imagine the roar of a waterfall. It's a powerful sound, but it's made up of thousands of different tones and frequencies all blended together. It's a messy, complex sound. That is what we call broadband. Most natural radio sources in space are like this. Stars, galaxies, pulsars, they all emit radio waves across a wide range of frequencies. They create a cosmic roar, not a clear note. Now, imagine a single flute playing one perfect, clear, sustained note. It's a pure tone. It exists on a very specific, very narrow frequency. That is a narrowband signal. The wow signal was a flute note in a universe of waterfalls. It was an incredibly narrow signal, occupying a tiny slice of the radio spectrum, less than 10 kilohertz wide. Natural phenomena just don't do that. Nature is messy. It splashes radio energy all over the dial. To create a narrowband signal, you need technology. You need a transmitter. You need an intelligence that has deliberately focused energy into a single, pure beacon. So let's recap the evidence. We have a signal that is incredibly strong. A signal that came from a fixed point in deep space. A signal broadcast on the most logical frequency in the universe for interstellar communication. And a signal that was narrowband, a telltale sign of technology. You can see why Jerry Emmon wrote, "Wow!" It was the perfect candidate for a signal from an extraterrestrial intelligence. It ticked all the boxes. For a brief, shining moment, it seemed like we had done it. We had found proof that we are not alone. The news spread, first quietly within the astronomy community, and then more broadly. The team at the Big Ear was ecstatic, but also cautious. Science demands proof. And the most important proof is repeatability. If you find something once, you must be able to find it again. So they went back to listening. Dr. John Krauss, the director of the Big Ear Observatory, and Dr. Robert Dixon, his assistant director, focused all their efforts on that small patch of sky in Sagittarius. They pointed the Big Ear back to the exact coordinates. They listened, night after night, week after week, month after month, and they heard nothing. Only the familiar, gentle hiss of the cosmos. The signal was gone. It had been a one-time event, a 72-second whisper that had vanished as quickly as it came. Other, more powerful telescopes around the world also took a look. The giant dish at Arecibo in Puerto Rico, the very large array in New Mexico. They scanned the same patch of sky. They listened on the same frequency. They searched for that beautiful narrow-band flute note. Silence. The cosmic shout had faded back into a whisper, and the great mystery began. What was the wow? Signal? Where did it come from? And why has it never been heard again? This is where the story shifts from a thrilling discovery to a fascinating cosmic detective story. For over 40 years, scientists, skeptics, and dreamers have proposed dozens of theories. Let's explore them, one by one, like peeling the layers of an onion. The first and most exciting theory is, of course, the one that made Jerry Emmon write his famous word, the extraterrestrial intelligence hypothesis. The idea that the signal was a deliberate beacon from an alien civilization. Let's allow ourselves to dream for a moment. Let's imagine a world orbiting a star in the constellation Sagittarius, about 1,800 light years away. A civilization far older and perhaps wiser than our own. Maybe they had been watching the cosmos for millennia. Maybe they had discovered the laws of physics, built radio telescopes, and come to the same conclusion we did, that we are part of a vast cosmic community. And perhaps they decided to say, hello. Why would they send a signal like this? It could have been a beacon, a cosmic lighthouse sweeping across the galaxy. Just a simple pulse that says, we are here, we exist. A powerful, efficient way to announce your presence without needing to send a complex message. Think of it like a cosmic smoke signal. The signal's structure supports this idea. It was a single, unmodulated pulse. There was no complex information encoded in it, no alien music or mathematical formulas. It was just a pure, powerful tone. This is exactly what you would do if you were trying to get someone's attention across the vastness of space. You wouldn't start with a long, complicated speech. You would shout, hey, first. The wow signal could have been that, hey, And what about the fact that it never repeated? If it were a beacon, wouldn't it flash regularly? Not necessarily. The source could be a transmitter on a planet that is rotating. So, its beam would only sweep past Earth for a brief period every day or every year. Or maybe the beacon itself is rotating, like a lighthouse, and its beam only illuminates our tiny corner of the galaxy once every few decades or centuries. We might have just been lucky enough to be looking in the right direction at the exact right moment. A 1 in a trillion chance. This idea has been championed by many in the SETI community. Dr. Jill Tarter, a pioneering astronomer and the former director of the Center for SETI Research, has spent her life searching for signals like this. She was the inspiration for the character of Ellie Arroway in Carl Sagan's novel and the movie Contact. Dr. Tarter represents the hopeful, patient, and scientifically rigorous heart of this search. She would argue that a single, unrepeated signal is not a failure. It is a data point, a tantalizing clue that tells us where to keep looking and what to listen for. She reminds us that the search for extraterrestrial intelligence is not a sprint. It is a marathon that could span generations. The wow signal in this view is the first lap. But science requires us to be skeptical. We must explore all other possibilities before we can jump to the extraordinary conclusion of alien life. So, let's put on our detective hats and consider the other suspects. The next category of explanations involves natural but unusual astronomical phenomena. For a long time, this category was mostly empty. No known natural source, no star, no nebula, no black hole, was known to produce a signal that was both so powerful and so narrowband. Nature, as we said, likes to be messy. However, in 2017, a new theory emerged that caused a big stir. A professor from St. Petersburg College in Florida, named Antonio Paris, proposed a novel idea. He suggested the signal could have been caused by a comet. This sounds strange at first. Comets are giant, dirty snowballs of ice and rock. They don't have transmitters. But they are surrounded by something very important, huge clouds of hydrogen gas. As a comet gets closer to the sun, the solar radiation causes the ice to vaporize, releasing a massive, invisible halo of hydrogen gas that can stretch for millions of kilometers. Professor Paris's theory was that the Big Ear telescope might have passed over one of these hydrogen clouds. The intense radio energy from the sun, or another powerful source, could have stimulated this hydrogen cloud, causing it to emit a burst of radio waves at, you guessed it, the hydrogen line frequency of 1420 megahertz. It was a clever idea. It seemed to explain the frequency. And it could explain why the signal is never seen again. Comets move. They don't stay in one place. By the time astronomers went back to look, the comet would have been long gone, its hydrogen tail somewhere else in the solar system. To test his hypothesis, Professor Paris found two comets, named 266P Christensen and 335P Gibbs, that were in the right patch of sky in Sagittarius on August 15, 1977. They hadn't been discovered back then. But by calculating their orbits backwards, he showed they were in the vicinity of the WOW, signal's origin point. He then used a modern radio telescope to observe these comets and claimed to have detected a similar, though much weaker, signal at 1420 megahertz. For a moment, it looked like the mystery might be solved. The media loved the story. Mystery of WOW. Signal solved. It was a comet, the headline screamed. It was a neat, tidy, natural explanation. But the scientific community was not convinced. The original team from the Big Ear Observatory, including Dr. Emin himself, quickly pointed out several major problems with the comet theory. First, the comets Paris identified were very faint. It's highly unlikely their hydrogen clouds would be large or dense, enough to produce a signal 30 times stronger than the background noise. It would be like trying to create a tidal wave by throwing a pebble in the ocean. Second, if this phenomenon were common, if comets regularly produced such strong signals when passing through a telescope beam, we should have seen it happen again. We have been observing the sky with radio telescopes for over 60 years. Thousands of comets have passed through our fields of view. Yet, we have never seen another wow signal from any of them. It remains a unique event. Third, and perhaps most damning, was the shape of the signal. Remember the 72-second curve? The perfect rise and fall that matched the telescope's observation window? A comet's hydrogen cloud is a huge, diffuse, and blob-like object. It's not a single point source like a distant star. A signal from a comet's cloud would likely be smeared out, lasting much longer than 72 seconds as the telescope beam slowly scanned across the vast, gassy halo. The signal Dr. Emin found was sharp and precise. It looked like it came from a single, compact source, far away. So, while the comet theory was an excellent example of creative, outside-the-box thinking, it ultimately failed to explain the key features of the signal. The cosmic detective story was not over. The suspect had an alibi. The case remained open. So, if it wasn't aliens, and it wasn't a comet, what else could it be? This brings us to the third, and perhaps most mundane category of explanations: terrestrial interference. This is the idea that the signal was not from space at all. It was a signal from Earth that somehow bounced or reflected off something in orbit and came back down into the Big Ear's receiver. Let's picture this. Imagine a powerful radio transmitter on the ground, perhaps a military base or a weather experiment. It sends a signal up into the sky. That signal travels up, hits a piece of space debris, an old satellite, a discarded rocket booster, or even a metallic weather balloon, and then reflects back down to Earth, right into the path of the Big Ear telescope. This is a very real possibility. Our planet is surrounded by a cloud of our own technological noise. We are constantly bathing the Earth in radio waves, television signals, radar, and satellite communications. It is one of the biggest challenges for SETI astronomers. It's like trying to listen for a pin drop during a rock concert. This theory could explain some things. It could explain why the signal was narrowband. Our own technology produces narrowband signals. It could explain why it was never seen again. The specific alignment of a ground transmitter, a piece of space junk, and the telescope would be a fleeting, random event, almost impossible to replicate. But this theory also has its problems. Big ones. First, the frequency. 1,420 megahertz, the hydrogen line, is a protected part of the radio spectrum. By international agreement, this band is kept clear for radio astronomy. Transmitting on this frequency is strictly forbidden in most parts of the world. It's a quiet zone. While it's possible a secret military satellite or an illegal transmitter was using it, it is highly unlikely. Second, and more importantly, is that 72-second signature again. For a reflected Earth-based signal to perfectly mimic the rise and fall of a deep space object passing through the telescope's beam, the reflecting object would have to be moving at just the right speed and trajectory to appear stationary relative to the distant stars. This is incredibly improbable. Space debris orbits the Earth at thousands of miles per hour. It would have zipped through the Big Ear's view in a matter of seconds, not the leisurely 72 seconds that were observed. The signal behaved like something very, very far away, not like something from our own backyard. So, the terrestrial interference theory, while plausible on the surface, doesn't quite fit the evidence. The alibi for this suspect is also quite strong. We are running out of options. We've considered aliens, comets, and earthly signals. This leads us to our final, and perhaps least satisfying, possible explanation. A simple glitch. Could the entire thing have been a mistake? A malfunction in the telescope's electronics or the computer system? This is the "did you try turning it off and on again" theory of cosmology. It's always a possibility, especially with older, custom-built equipment like the Big Ear. Maybe a power surge or a faulty component created a false signal that just happened to look incredibly interesting. Maybe the computer just had a hiccup and printed out a string of nonsense characters. But this theory is widely considered the least likely of all. The reason is the signal's structure. It wasn't just a random burst of static. It was a beautifully structured event. It rose and fell in a perfect bell curve over exactly 72 seconds. It appeared in only one of the telescope's 2 feed horns, or receivers, which is what you would expect from a true celestial signal. A glitch or a burst of internal static would likely have shown up in both receivers simultaneously. To believe it was a glitch, you have to believe in a truly staggering coincidence. You have to believe that a random electronic malfunction perfectly mimicked a signature of a deep space object on the most significant frequency for interstellar communication at an intensity ever seen before or since. It stretches the bounds of credulity. As one astronomer put it, a glitch that perfect would be almost as mysterious and exciting as the signal itself. So, where does that leave us? We are left with a profound and beautiful mystery. We have a signal that looks like a message from an alien intelligence. It acts like a message from an alien intelligence. It sounds like a message from an alien intelligence, but we have no other proof. No repeat performance. No confirmation. It's a single, tantalizing data point. A cosmic question mark. Let's just sit with that feeling for a little while. The feeling of the unknown. In our modern world, we are used to having answers at our fingertips. We can Google any question, find any fact, but the universe doesn't work that way. The universe is full of mysteries that may take centuries to solve, if they are ever solved at all. And perhaps that is a good thing. Mysteries keep us curious. They keep us looking up. They keep us asking the big questions. The story of the wow. Signal did not end in 1977. Its legacy continues to inspire a new generation of scientists and new ways of searching. The Big Ear telescope is gone now. It was dismantled in 1998 to make way for a golf course expansion. A quiet end for such a historic instrument. But its spirit lives on. Today, the search for extraterrestrial intelligence is more sophisticated than ever. Projects like the Breakthrough Listen initiative, funded by billionaire Yuri Milner, are using the world's most powerful radio telescopes to conduct the most comprehensive survey ever attempted. They are scanning 1 million nearby stars and the 100 closest galaxies. They are collecting petabytes of data, an amount so vast it would have been unimaginable to the team at the Big Ear with their paper printouts. These modern searches are looking for signals like wow. They are specifically looking for narrowband signals on interesting frequencies. and they are using advanced computer algorithms to sift through the cosmic static, looking for that one flute note in the waterfall's roar. Scientists are also thinking of new ways to look. Some are looking for laser flashes instead of radio waves, theorizing that a more advanced civilization might use light to communicate. Others are searching for technosignatures, a broader category of evidence. This could be anything from the chemical signature of industrial pollution in a planet's atmosphere to the heat signature of massive alien engineering projects, like a Dyson sphere built around a star. The search has broadened, but the wow signal remains the benchmark, the golden standard. It is the one that got away. Let's go back to Dr. Jerry Emmon. He spent the rest of his life puzzling over those 72 seconds of data. He never claimed it was aliens. As a scientist, he remained cautious and open-minded. He meticulously investigated and debunked dozens of terrestrial explanations. He continued to hope for a repeat signal, a confirmation that what he saw was real. He passed away in 2009, the mystery still unsolved. His wow note, scribbled in red ink on that old computer printout, is now a legendary artifact in the history of science. It's a symbol of that magical moment where the mundane reality of data analysis collided with the extraordinary possibilities of the cosmos. And what about that patch of sky in Sagittarius? Where did the signal come from? The Big Ear's resolution wasn't very good. It could only narrow down the location to a region of the sky that still contained thousands of stars. It's like knowing a letter came from a big city, but not knowing the street address. The constellation Sagittarius itself is a fascinating place to look. When we look towards Sagittarius, we are looking towards the bustling, crowded center of our own Milky Way galaxy. It's the downtown core of our galactic city. It is teeming with stars, old and new. It's a region of intense star formation and cosmic activity. If there are other intelligent civilizations in our galaxy, the galactic center is a logical place to find them. It's where the action is. Over the years, astronomers have tried to pinpoint the source more precisely. They have surveyed the stars in that region. One star, known as Tau Sagittarii, was once considered a prime candidate, but more precise measurements showed it was slightly outside the signal's probable location. More recent surveys have identified other, more plausible sun-like stars in the area. Stars that could, theoretically, host planets. Worlds that could, theoretically, host life. But without a second signal, it's all just speculation. Hopeful, wonderful speculation. Let's take a deep breath and visualize the journey of that signal. Imagine a single pulse of radio energy, born from a transmitter we cannot fathom. It leaves its source and begins a long journey through the void. For hundreds, or perhaps thousands of years, it travels at the speed of light. It passes through wispy clouds of interstellar dust. It glides past the gravitational fields of giant stars. It sails through the silent, empty spaces between solar systems. It is a lonely traveler, carrying a single, simple message. We are here. For all those centuries, it is unheard, unseen, a silent whisper crossing an impossibly large ocean. And then, in the vastness of time and space, it happens to arrive at a small, blue-white planet, a world teeming with life. And on that planet, by sheer chance, a curious species has built a giant metal ear. And that ear just happens to be listening to the right patch of sky, on the right frequency, at the exact moment the signal washes over it. For 72 brief seconds, the ancient whisper is caught. It is recorded. It is seen by a human eye. And for a moment, the universe feels a little less empty, a little less lonely. Then, just as quickly, the signal continues on its journey, out of our solar system and back into the void, perhaps to travel for another 1,000 years before it fades completely into the background noise of the cosmos. Whether it was a deliberate message, a strange natural fluke, or a 1 in a billion reflection, the wow signal changed something. It solidified the search for extraterrestrial intelligence as a serious scientific endeavor. It captured the public imagination in a way that dry scientific papers never could. It gave us a story, a cosmic campfire tale. It reminds us that the universe is vast and strange, and full of wonders we are only just beginning to comprehend. It teaches us a lesson in humility. We are a very young species on a very small world. We have only been listening for a few decades. That's a mere blink of an eye in cosmic time. To expect an immediate answer is perhaps a bit impatient. The work of people like Jill Tarter, Jerry Emmon, John Krauss, and all the others who have dedicated their lives to this search is a testament to human curiosity and hope. It is an expression of our deepest desire to know our place in the universe, to find out if we are alone in this vast, dark expanse, or if there are others out there looking up at their own stars and wondering the same thing. The silence that followed the wow signal is not an answer. It is not a no. It is simply a pause. The universe has asked a question in the form of a 72-second signal, and we are still working on our reply. Our reply is our continued listening. Our reply is our ever-improving technology. Our reply is our unyielding curiosity. So as you drift off to sleep tonight, let the mystery of the wow signal be a comforting thought. It's a reminder that we live in a universe of infinite possibilities. A universe where a simple sequence of letters on a piece of paper can change the world. A universe that can still, after all this time, make us look up and say, wow. Think about the quiet patience of it all. The big ear sitting in its field for years, just listening. The earth turning, slowly bringing new stars into view. The long, patient sifting of data, day after day. It's a slow, meditative process. A kind of cosmic mindfulness. Let your own mind be like the big ear tonight. Quiet, patient, listening, not for any specific sound, but just aware of the gentle hum of the world around you. The sound of your own breathing. The distant rumble of a passing car, the quiet settling of your home. These are your own background signals, your own terrestrial noise. And beneath it all, there is a deep, profound silence. The same silence that fills the space between stars. Let's think about that frequency again. The hydrogen line. The universe's own radio station. It's a beautiful thought, isn't it? That the most common thing in the universe, the simple hydrogen atom, provides a common ground for communication. It's a fundamental constant, a piece of shared reality for any technological species, no matter how different they might be from us. They might not have eyes or ears. They might be made of silicon instead of carbon. They might live in oceans of methane. But they would know about hydrogen. They would have to. It's the basic building block of their own stars. It connects us. The same hydrogen atoms that are in the sun, in the great nebulas, in the clouds between galaxies, are also in the water you drink, in the air you breathe. In you, you are made of stardust. You are tuned to the same cosmic frequency. The mystery of the wow signal is not a frustrating puzzle. It is an invitation to wonder, an invitation to be curious, and an invitation to be patient. The universe does not give up its secrets easily, and that is what makes them so precious. As you feel your body getting heavier, your breathing getting slower, just let these thoughts drift. The giant metal ear, the roll of paper, the red circle, the silent stars of Sagittarius, the 72-second whisper. It's a story with no ending. A mystery that may never be solved, and that's okay. Some stories are not meant to have a neat conclusion. They are meant to open our minds, to stretch our imagination, to rock us to sleep with the gentle rhythm of the unknown. The universe is under no obligation to make sense to us, but it is always there, waiting to be explored, waiting to be heard, waiting for another wow moment. The silence that followed the wow signal was not an emptiness. It was a beginning. It was the start of a quest that continues to this very day. In the weeks and months after August 15th, 1977, the team at the Big Ear did the most logical thing they could do. They kept listening. Dr. John Krauss and Dr. Robert Dixon, the leaders of the observatory, directed the telescope's gaze back to that specific patch of sky in Sagittarius. They were scientists. They knew that a single discovery, no matter how exciting, is meaningless without confirmation. They needed the signal to come back. They needed to hear that cosmic shout a second time. Imagine the atmosphere at the observatory during that time. A quiet, tense excitement. Every new roll of computer paper that spooled out of the printer was examined with a hope that bordered on prayer. They would scan the columns of numbers and letters, their eyes searching for that telltale spike, for another E or Q, or U for another wow moment. They conducted over 50 more observations of the region in the years that followed. They listened with a patience that only astronomers truly understand, but the signal never returned. The patch of sky remained stubbornly, maddeningly silent. It was as if a door had opened for a brief moment, showing them a glimpse of something extraordinary, and then had shut again, leaving them in the quiet hallway of the known universe. The failure to detect the signal again at the Big Ear was disappointing, but not defeating. It simply meant the search had to get bigger. The mystery of the wow signal was too important to be left to a single telescope. And so, the call went out to the global community of astronomers. The cosmic baton was passed to larger, more powerful ears. One of the first to take up the search was the Arecibo Observatory in Puerto Rico. Let us take a moment to picture this magnificent instrument. It is not like the Big Ear's simple fence-like design. Imagine a colossal bowl, 1,000 feet across, woven into the natural limestone hills of the Puerto Rican jungle. It was so large it could hold billions of bowls of cereal. For over 50 years, this was the largest and most sensitive single-dish radio telescope on Earth. It was our planet's premier ear, listening to the faintest whispers from the edge of time. Above the giant dish, suspended by cables from 3 massive towers, was a 900-ton platform of receivers and transmitters. It looked like a futuristic spider, hovering over a giant silver web. Arecibo could listen with a sensitivity that dwarfed the Big Ear. If the wow signal was a shout in Ohio, Arecibo could have heard a whisper from the same source. Scientists, including Jill Tarter and the team at the SETI Institute, used Arecibo to stare at the wow signal's location for hours on end. They pointed that immense dish towards Sagittarius and listened. They listened with a focus and precision that was impossible in 1977. They scanned not just the hydrogen line, but millions of other channels around it. They were searching for any hint of that narrowband beacon. Visualize the scene: the warm, humid air of the jungle, the chirping of the coqui frogs, and in the center of it all, this vast, silent dish aimed at the heavens, collecting the faint, ancient light of the stars. It was a place of immense technological power, yet it felt like a sacred temple dedicated to the cosmos. But even Arecibo heard nothing. The silence from that region of space was profound. It deepened the mystery. The signal wasn't just a faint burst that the big ear had been lucky to catch. It was either a true one-time event, or it was gone. The search didn't stop there. In the mountains of West Virginia, nestled in a valley protected by law from earthly radio interference, sits another great instrument. The Green Bank Telescope, or GBT. It is the world's largest fully steerable radio telescope. Unlike Arecibo, which was fixed in the ground, the GBT can move. It can tilt and turn, tracking objects across the sky with incredible precision. It stands taller than the Statue of Liberty, a graceful white giant against the green hills. The area around the GBT is a national radio quiet zone. This means that things like Wi-Fi, cell phones, and even microwave ovens are heavily restricted or banned outright. It is a place dedicated to silence. It's like a national park, but instead of protecting trees and animals, it protects the ability to hear the universe. It is one of the quietest technological places on Earth. In recent years, the GBT has also taken up the search. Armed with modern computers and receivers, it has performed some of the deepest ever searches of the WOW signal's location. These new searches are far more comprehensive than anything that came before. They don't just look at one star. They can observe thousands of stars at the same time, sifting through billions of radio channels simultaneously. Imagine a detective returning to a cold case from 40 years ago. But now, the detective has incredible new forensic tools. DNA analysis, digital databases, satellite imagery. That is what the new searches with the GBT are like. They are re-examining the old evidence with new eyes and new ears. And still nothing. The silence persists. The search has also gone global. The Parkes Observatory in Australia, another giant dish famous for its role in receiving the television signals from the Apollo 11 moon landing, has also listened. Telescopes in Europe and Asia have joined the quiet hunt. The WOW signal has become a point of pilgrimage for radio astronomers, a place to return to check in on, just in case. The nature of the search has also evolved. At first, it was about redetecting the original signal. Now, it's more of a broad survey. Astronomers have used data from space telescopes, like the Gaia mission, to create a detailed 3D map of the stars in the WOW signals region. They are looking for candidates. For stars that are like our own sun. Stars that are the right age and composition to potentially harbor life-bearing planets. Just recently, an amateur astronomer named Alberto Caballero did just that. He painstakingly sifted through the Gaia star catalog. He was looking for a star in that specific patch of sky that was a close twin to our own sun, a solar analog. After a long search, he found one. A star designated 2M-Oz S1 928198226400123. It's not a very catchy name, but it is a star almost identical to our sun, located at the right distance in the right direction. This doesn't mean this star is the source. It's just another clue, another breadcrumb on the long trail. But it gives future searchers a specific target, a specific front door to listen at. Instead of searching the whole city, they can now focus on a single, promising-looking house. And the search has also become a collaborative effort, open to everyone. You may have heard of a project called SETI at home. It was a brilliant idea born in the late 1990s. The amount of data collected by radio telescopes is enormous. Too much for the scientists and their university supercomputers to analyze alone. So they asked for help. They created a program that anyone could download. This program would run in the background on your home computer, like a screensaver. When you weren't using your computer, it would download a small chunk of data from the Arecibo telescope, analyze it for interesting signals, and send the results back. Millions of people around the world participated. It was a global supercomputer made of millions of ordinary PCs, all working together to search for a needle in a cosmic haystack. It was citizen science on a grand scale. It connected people directly to the search. It made them part of the quest. While SETI at home didn't find the wow, Signal again, it analyzed more data than any project in history and proved the power of collaboration. It showed that the search for our place in the cosmos is a journey for all of humanity. So the search continues. It is slower now, more patient. The initial frantic hope has been replaced by a long, steady, scientific determination. The wow signal is no longer a hot lead. It is a cold case, but it is the most famous cold case in the history of astronomy, and a case that no one is willing to close. The legacy of the wow signal extends far beyond the ongoing search for its source. Its impact on science and on us has been profound and lasting. It has become more than just a piece of data. It is a story, a symbol. Let's think about its scientific legacy first. The wow signal became the gold standard for what a potential extraterrestrial signal should look like. It became the template, the type specimen in the Museum of SETI. Before 1977, the search for alien signals was highly theoretical. Scientists like Frank Drake, who created the famous Drake equation to estimate the number of civilizations in our galaxy, had laid the groundwork. But they didn't know exactly what they were listening for. The wow signal provided a concrete example. It showed them the key characteristics to prioritize: a narrowband signal on a logical frequency that appears to come from a fixed point in space. This had a huge influence on the design of all subsequent SETI projects. The search algorithms, the computer programs that sift through the data, were written with the wow signal in mind. They are specifically programmed to flag anything that looks like it. Anything with that sharp, narrow, artificial-seeming profile. In a way, every SETI search since 1977 has been, in part, a search for another wow signal. It also had a more subtle, but equally important, impact on the scientific community. The search for extraterrestrial intelligence has not always been seen as mainstream science. For a long time, it was on the fringe. It was considered highly speculative, a bit too close to science fiction for many serious academics. In the 1970s, a United States senator named William Proxmire created something called the Golden Fleece Award. He gave this award to government-funded projects that he considered to be a waste of taxpayer money. In 1978, he gave the award to SETI. He ridiculed the idea of spending money to look for little green men. This created a chilling effect. It made it very difficult for SETI projects to get government funding from agencies like NASA. For decades, The search had to rely on private donors and passionate volunteers. The wow signal became a powerful counterargument to this kind of ridicule. How could the search be a complete waste of time when it had already found this unexplained, tantalizing, perfect candidate signal? It didn't solve the funding problem overnight, but it gave the scientists in the field a crucial piece of evidence. It gave them credibility. It showed that the search wasn't just a fantasy. There were real, measurable, mysterious things out there to be investigated. Perhaps the most important legacy, though, is the human one. The inspiration. Imagine you are a young student in the 1980s. You love science. You love science. You read books by Carl Sagan, and you hear the story of the wow signal, the story of a volunteer scientist looking at a simple paper printout and finding a whisper from the stars. That story could change your life. It could be the spark that makes you decide to become an astronomer, an engineer, a physicist. The wow signal is a gateway story. It's a way into the vast and sometimes intimidating world of astrophysics. It's not about complex equations or abstract theories. It's about a single, understandable moment of discovery, a moment of pure awe. It tells us that the universe is not just a cold, empty place governed by remote physical laws. It is a place of mystery, wonder, and possibility. That inspiration continues today. The story is told in university classrooms, in planetariums, and in documentaries. It is often the first thing people learn about when they become interested in SETI. It fuels the work of organizations like the SETI Institute, where scientists like Seth Shostak carry on the search. He is the senior astronomer at the Institute, and he is also a wonderful communicator. He often speaks about the wow signal, not as definitive proof, but as the great motivator, the event that keeps everyone searching, because it showed us that finding such a signal is, at the very least, possible. And we should also remember the quieter legacy, the legacy of the people behind the signal. It wasn't just one famous scientist. It was a team. It was John Krause, the visionary who designed and built the Big Ear with his students on a shoestring budget. It was Robert Dixon, who managed the observatory and kept the search going for years. It was the engineers and technicians who kept the aging telescope running. And it was Jerry Emin, the volunteer, who gave his free time out of pure passion and curiosity. The story of the wow signal is a beautiful reminder that science is a deeply human activity. It's driven by collaboration, by dedication, and by that simple, powerful, shared emotion of wanting to know what's out there. Let's take a moment to drift into the world of popular culture. For a story to truly last, it needs to escape the confines of the laboratory and the classroom. It needs to enter our shared imagination. The wow signal did this in a spectacular way. It became a cultural icon. If you have ever watched the TV show The X-Files, you might remember an early episode. The main character, Fox Mulder, is obsessed with finding proof of alien life. In this episode, it is revealed that his obsession began when he was a child, listening to the very first broadcast from the Voyager space probe. But the real breakthrough in the episode comes when the agents find a tape recording from a defunct radio observatory. On that tape is a 72-second signal, a powerful narrowband burst from the constellation Sagittarius. It is, of course, a fictionalized version of the wow signal. It serves as the show's proof, the one piece of hard data in a world of shadows and conspiracies. This is just one example of dozens. The signal has been referenced in books, movies, and music. It has become a piece of shorthand, a symbol. When a writer wants to quickly establish the idea of a real scientific mystery related to aliens, they use the wow signal. It has also become a fixture in the wider public conversation about life in the universe. It often appears in documentaries about UFOs and ancient aliens. In these contexts, it is sometimes presented as the smoking gun, the definitive proof that we have been contacted. It's interesting to see how the story changes depending on who is telling it. For a scientist like Jill Tarter, the signal is a candidate. It's an intriguing data point that requires more evidence. It represents a question. For a science fiction writer, it is a plot device, a catalyst for a story. For a UFO enthusiast, it is an answer. This doesn't mean one view is right and the other is wrong. It simply shows the power of the signal. It is a story that is big enough to hold all of these different meanings. It reflects our own hopes, our fears, our skepticism, and our deep-seated desire for connection. Let's visualize this cultural impact. Imagine the iconic image of the printout, the clean columns of computer text, the hand-drawn red circle, and that one perfect word. Wow! That image has been printed on T-shirts. It has been turned into posters. It's on coffee mugs. The sequence of characters, 6EQJ5, has become a kind of code, a secret handshake for people who love space and mystery. It is the phone number for the universe, even if no one answers when we try to call it back. The signal has given us a shared piece of cosmic folklore, a modern myth, but a myth with a fascinating twist. It really happened. The data is real. The telescope was real. The mystery is real. It blurs the line between science fiction and science fact in a way that is endlessly fascinating. It allows all of us, not just the scientists, to participate in the wonder of the search. Now, let us gently return to the science. Why, after all this time, all these powerful telescopes, and all this brain power, does this mystery remain unsolved? Why can't we just figure it out? The answer lies in the deep and difficult challenges of listening for whispers in a noisy universe. The biggest challenge is the one we have already touched upon, the problem of non-reproducibility. In science, the ability to repeat an experiment or an observation is everything. It is the foundation of proof. If a chemist discovers a new reaction in a test tube, other chemists in other labs must be able to follow the recipe and get the same result. If they can't, the discovery is not considered valid. The wow signal is a single unrepeated observation, a singleton. Let's use an analogy. Imagine you are walking on a vast, empty beach. You look down and you see a single, perfect footprint in the sand. It's a footprint unlike any you have ever seen before. It's not human. It's not from any animal you can recognize. It's beautiful and strange. You have proof that something walked here. You have the footprint. But that's all you have. You don't know how big the creature was. You don't know if it had 2 legs or 4. You don't know how fast it was moving. You don't know where it came from or where it went. And most importantly, you don't know if it will ever walk on this beach again. You can wait. You can watch. You can scan the horizon. But until you see the creature that made the print, or at least find another print, the footprint remains a profound and deeply frustrating mystery. The wow signal is that single perfect footprint on the cosmic shore. It is a tantalizing clue, but it is not enough to build a case. Without a second signal, we are left to speculate. This leads to the second major challenge, the sheer lack of data. You might think that 72 seconds of data is a lot, and in some ways, it is. It gave us the signal's strength profile, its duration, its frequency. But in other ways, it is an incredibly small amount of information. The most crucial piece of missing data comes from the design of the Big Ear telescope itself. The Big Ear had two receivers, two feed horns. They were positioned side by side. Their purpose was to provide confirmation. As the Earth rotated, a signal from space would pass through the first feed horn. Then, a few minutes later, it would pass through the second one. A real celestial signal should appear in the first horn, disappear for a few minutes, and then reappear in the second horn. Let's visualize this. Imagine you have set up two cameras to watch a racetrack. The cameras are 100 yards apart. You are watching for a specific, mysterious car. If the car is real and is driving on the track, it will appear on camera 1. Then a few seconds later, it will appear on camera 2. This confirms it's a real car on the track. But what if the car appears on camera 1 and then vanishes and never shows up on camera 2? What happened? Did it crash? Did it turn off the track? Was it just a weird reflection on the lens of the first camera? You can't be sure. This is exactly what happened with the WOW signal. It was detected loud and clear by one of the Big Ear's feed horns. But it was gone by the time the second feed horn swept over that same patch of sky. Dr. Emin looked at the data from the second horn. There was nothing there, just static. This has always been a point of contention. For skeptics, this is a red flag. It suggests the signal might not have been truly celestial. Perhaps it was a short-lived burst of terrestrial interference that just happened to occur when the first horn was looking. For proponents of an extraterrestrial origin, there is a simple explanation. The alien transmitter might have simply been turned off. The signal might have lasted for only a minute or two. We were lucky to catch it for 72 seconds. But by the time the second horn looked, the broadcast was over. The cosmic lighthouse had switched off its lamp. Either way, the lack of that second detection leaves us with a critical piece of the puzzle missing. It's another layer to the enigma. We don't know if there was any information encoded in the signal. A modulated signal can carry a message, like the way AM or FM radio carries music and voices. The WOW signal appeared to be unmodulated, a pure tone. But was it? We only have 72 seconds. The message might have started at second 73. We will never know. The third great challenge is the one that plagues all modern city searches. The problem of telling our own noise apart from a potential alien signal. This is called radio frequency interference, or RFI. Our planet is now a blazing star in the radio spectrum. We have created a technological noisosphere that surrounds the Earth. Every second of every day, we are broadcasting thousands of signals. Television, radio, cell phones, GPS satellites, Wi-Fi routers, radar for ships and planes. Even our microwave ovens leak a small amount of radio energy. Trying to find a faint, distant signal from another star amidst this cacophony is one of the hardest tasks in all of science. Let's use another visualization. Imagine you are in the middle of a massive, crowded, noisy stadium during the final seconds of a championship game. Tens of thousands of people are shouting and cheering. The loudspeakers are blasting music, and your task is to hear the sound of a single tiny bird chirping from the other side of the stadium. That sounds impossible, doesn't it? That is the challenge facing SETI astronomers. They are trying to hear a cosmic bird chirp in the middle of a global stadium roar. Modern astronomers have developed incredibly clever ways to deal with this. They use multiple telescopes at once. A real signal from space will arrive at one telescope a split second before it arrives at another one a few miles away. A signal from a nearby satellite or airplane will arrive at both at almost the same time. Computers can use this timing difference to filter out local noise. They also have vast databases of all known human-made signals. If a signal matches the frequency and characteristics of a GPS satellite, the computer automatically ignores it. But the WOW signal was detected in 1977, before all of this sophisticated filtering technology existed. This makes its status even more remarkable and also more questionable. It did not seem to match any known terrestrial signal at the time, and it was on that protected hydrogen line frequency. But we can't be 100% sure. The possibility that it was some unknown, unusual form of earthly interference can never be completely eliminated. It's a ghost that will always haunt the mystery, a nagging doubt in the back of the mind. So after decades of searching, after poring over the data, after considering all the theories, from the mundane to the magnificent, we are left in a state of beautiful uncertainty. The WOW signal remains an unsolved mystery, an enigma. Science is not always about finding answers. Sometimes it is about learning to ask better questions. And sometimes it is about learning to live with a mystery, to accept that there are things we do not yet understand, and to find a sense of peace and wonder in that not knowing. The statement, "we don't know," is not a statement of failure. It is a statement of honesty. It is the engine of scientific progress. It is the starting point for every new journey of discovery. The story of the WOW signal does not have a conclusion. It is a story that is still being written. It fuels the speculation and the dreams of those who look at the night sky and wonder. The possibility that we are not alone. The idea that somewhere out there, another civilization might be sending out its own whispers, its own hellos, into the vast cosmic ocean. The search for extraterrestrial intelligence continues, stronger and more sophisticated than ever. Projects like Breakthrough Listen are continuing the patient work of the Big Ear, but on an incredible new scale. They are listening with a sensitivity and a scope that would have seemed like pure science fiction to the astronomers of 1977. And somewhere on the horizon, new and even more powerful tools are being built. The Square Kilometer Array, or SKA, is an international project to build the largest radio telescope ever conceived. It will have antennas spread across 2 continents, Africa and Australia. When it is complete, its combined collecting area will be a full square kilometer. Let's try to grasp that scale. The SKA will be so sensitive that it could detect a standard airport radar on a planet orbiting a star 50 light-years away. It will be able to map the cosmic web of hydrogen gas throughout the universe. It will see the birth of the very first stars and galaxies. And of course, it will listen. It will listen for technosignatures, for signals like WOW, but with a clarity and a power we have never had before. Perhaps one day, the SKA, another future telescope, will detect a signal that is strong, narrowband, and on a logical frequency. And perhaps this time it will repeat. Perhaps it will stay on long enough for us to confirm it, long enough for us to study it. Maybe it will even contain a message. Until that day comes, we have the WOW signal A 72-second story. A cosmic question mark. A reminder that we live in a universe that is far more strange, more beautiful, and more mysterious than we can possibly imagine. It invites us to keep looking up, to keep listening, and to keep wondering. The search itself changes us. The act of looking for others in the cosmos forces us to look at ourselves. It makes us think about our own place in the universe. It makes us consider the long, fragile chain of events that led to our own existence on this small blue planet. It connects us to the great sweep of cosmic time. As you continue to relax, as your thoughts begin to soften and drift, let your mind become quiet. Let it become like the surface of a still lake on a moonless night. And on that surface, let the stars be reflected, each one a possibility, each one a distant sun. And among them, in the direction of Sagittarius, is a single point of light, a point from which a question was asked long ago. We are still listening for the echo. We are still contemplating the answer. The journey of that signal is a peaceful thought. Across the silent vacuum, for year after year, it flew. A tiny, organized ripple in the vast chaos of space-time. It was a fleeting pattern, a momentary order. And it found us. It found our little world. It was a brief intersection of two timelines. The timeline of a long-dead star, or a distant civilization, or a strange cosmic fluke, and our own human timeline of curiosity and discovery. That moment of intersection is what we call the wow signal. And it is a beautiful thing to ponder as you drift deeper and deeper into a state of restful peace. The universe whispered, and for a moment we heard it. And we are still listening.